All right, welcome to another IAEI News Live. My name is Thomas Dimitrovich, and today is Tuesday. And yes, I'm traveling again. I'm out and about. I'm in a hotel room. But remember, the show must go on. So I am in a hotel room, traveling abroad, but we are going to bring you another IAEI News Live. And today's topics, I think, might be an interesting one. We're going to talk about questions around markings on circuit breakers. Today on IAEI News Live. And it all starts now. All right, welcome back. So, this is a recorded session. As you can see, and hopefully you understand, this is a recorded session, and but I wanted to make sure that we had a good discussion. So today I want to review markings on circuit breakers. I've had questions come in just on different from a wide range of time periods. So I assembled a lot of those questions into a sort of a Q&A, and so that's what I'm going to talk about. So we're going to get through as many of these as we can. I'm going to try to hit some of the more interesting ones. But first off, the first thing I want to make sure that we all understand are basically the types of overcurrent protected devices, circuit breakers. There are medium and low voltage installations. I'm going to talk and focus on low voltage circuit breakers. That would be 1,000 volts and below. 1,000 volts AC, 1,500 volts DC, and lower in voltage rating. I'm not going to talk about medium voltage right now. The first type of circuit breaker, these are your circuit breakers that you would see closer up to the point of common coupling with the utility, closer to your service equipment. These are the big boys and girls, right? This is a big breaker. Your low voltage power circuit breakers. Now, I would argue all of these circuit breakers are going to have some sort of electronic trip units. They're all going to have some brain associated with them that has sensors, that is looking at the current flowing through that circuit breaker, and there's a microprocessor that is used to open or close that breaker. Pretty much open the breaker, but the microprocessor based system, if you have some of the other right components, you could close that circuit breaker as well from the either remote application or on the unit itself. Now, the low voltage power circuit breakers comply with the following standards. ANSI C37.16, this covers the preferred ratings. C37.17 are the trip devices for the low voltage power circuit breakers. Those are those trip units, okay? C37.50 are your test procedures, and then C37.13 are your low voltage power circuit breakers used in enclosures. So your C37 documents from IEEE are your typical IEEE references. They're ANSI documents, standards. And then you have UL 1066 for low voltage power circuit breakers. So that's sort of the, what would you call it? That's the list of standards, smorgasbord or whatever you want to call it, of standards. Now, let's talk molded case circuit breakers. Now, there are three types of circuit breakers. You have your low voltage power breaker, you have an insulated case circuit breaker, and a molded case circuit breaker. Now, I will tell you that your molded case circuit breaker and the insulated case circuit breaker, the standards, there is no technical, how do I say it? The insulated case, the term insulated case circuit breaker is a marketing term. It has nothing to do with a technical standard differentiation. It's not like you're going to go to a UL standard for insulated case circuit breakers, which is going to be different than the UL standards for molded case circuit breakers and different than the UL standards for power circuit breakers. Insulated case circuit breakers are listed to UL 489 for molded case circuit breakers, period. An insulated case circuit breaker is a molded case circuit breaker. End of story. The fact that we throw this term insulated case is a marketing differentiation of what this intermediate device is that gets you from the molded case solution to a power circuit breaker. It's that interim step. It's basically a beefed up molded case circuit breaker. So, I already said it. Molded case circuit breakers and molded case switches are listed to UL 489. Now, that's your UL reference. That's it. All right. So that just sort of gives you an overview of that. This slide here, this is sort of, what I like about this is that it gives you some differentiation. It shows you the column for low voltage power circuit breakers, which is this first column here. This tells you it's ANSI IEEE C37 UL 1066. Insulated case circuit breakers, UL 489. Molded case circuit breakers, UL 489. This also gives you the range that a low voltage power circuit breaker is anywhere from 800 amps to 6,000 amps. An insulated case, 8,000 amps to 800 amps to 5,000 amps. And then a molded case circuit breaker. Now, that molded case circuit breaker, the molded case circuit breaker says typically 100 to 2,500 amps, but you and I both know I can go down to a 10 amp circuit breaker molded case. And that's in Article 240, right? There's a table in there that shows you your standard ampere ratings. And we just recently added the 10 amp molded case circuit breaker. So I can get a molded case circuit breaker all the way down to 10 amps and all the way up to 2,500 amps. And that is still a molded case UL 489 device. Okay? But I do like this slide in that it gives you some of the really pertinent. Now here's some more information. Okay, here's a few more little tidbits of information. Series ratings not available in the power circuit breaker, not available in series ratings for insulated case circuit breaker, and it is available for the MCCB. That's your series ratings. You have a short time withstand, instantaneous. Where's the instantaneous? Short tan enclosures, maintenance enclosed ratings, relatively cost. I don't have an instantaneous. I have an interrupting rating. What I would say is that the molded case circuit breaker and the insulated case circuit breaker all have an instantaneous pickup. Power circuit breakers, only certain power circuit breakers, are probably a very rare portion of all the power circuit breakers sold out there, will have no instantaneous and just a short time only. So anyway, that little table, and you can pause that video and take a look at the video itself and get some things out of it. But it's a really good table. I like the overview that it provides. So first question up. Let's put this up on the screen. First question: are circuit breaker markings regulated by the NEC, product standards, other codes or standards, or do circuit breaker manufacturers provide the markings voluntarily to allow designers, installers, and AHJs with the use of the product? Good question. Good question. The answer to that is that the standards are what drives the markings. You're not going to have a code requirement that drives all of the marking requirements. Now, there are some marking requirements in the NEC, but for the most part, your circuit breaker markings are identified in UL 489 and associate or the appropriate standard, right? So UL 489 for the molded case and insulated case circuit breaker, 1066, I think it is, for power circuit breakers. So the standard is going to give you the requirements, and there's always a section in each of these standards that talk about markings. So if you have access to UL standards, then what you would do is go open the standard for whatever product it is that you're looking at and look for the section titled markings. And that will tell you how a product is supposed to be marked and labeled, and possibly, quite highly likely, that you'll also have the requirements for the instructions in the standards as well, if there are requirements for the instructions. And that aligns with Article 110, which references us and tells us that we should be looking for, I think it's 110.3b, tells us installing per the instructions that are a part of the UL listing of and labeling of the device. So if you see information in the instructions that are a part of the UL listing, if a manufacturer just elects to say, look, for example, another big hot topic, EV chargers. You'll see EV charger manufacturers. Do not put this on a GFCI circuit. You can't put instructions in the instructions language that basically says you don't have to follow the National Electrical Code. I can't put on my switchgear and switchboards and whatnot that says you do not need working space. The only working space you need is 4 inches in front of the equipment. If the code says you need X amount of feet or inches of working space, then you're going to apply that. It doesn't matter what the manufacturer's instructions say. And what the standards organizations do and work very hard to ensure is that the requirements that are in a standard do not conflict with the National Electrical Code. Very important that those two align, because then you may have issues. But suffice it to say, be careful what you read in some manufacturers' instructions, because they may not be 100% accurate. Always fall back on the listing. So, for example, circuit breakers in 489B for molded case circuit breakers, switches, and circuit breaker enclosures used for PV systems. This is a good example. Let's take a look at this. At this one, I should be able to go to. I know I have a screen in here that says "Me Teach." Me teach, you listen. Let me go to display. Oh wait, I know what to do. So I'm going to go to studio mode and go to display, and I'm going to open. There it is. Okay, so if I go Me Teach, there it is, and I'm going to transition. Boom, booyah. All right, so this is a good example of the marking requirements for a PV breaker. A PV circuit breaker shall be provided with the applicable required markings specified in Clause 9. A PV circuit breaker shall be marked photovoltaic or PV, location in Category B. Now, location categories tell you where the markings can be applied. So not only does the UL standard tell you what you need to mark on the product, but also where. PV circuit breakers shall be marked with an interrupting rating in accordance with 16.4, location category B. So suffice it to say that the UL standard is going to give you the marking requirements for these circuit breakers. Here's this. Yeah. Here we go. How about this one? Let's take a look at this one. This is for a multi-pole PV breaker shall be marked to indicate the proper configuration connections, notwithstanding 17.5. If there are multiple configurations, a separate document shall be included with the circuit breaker, and the circuit breaker shall be marked with a permanently affixed label that reads, for proper configuration of connections for the terminals, refer to publication number, blah, 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 blah. So if you have a separate document that should be accompanying that circuit breaker to give you information on how it is supposed to be configured and wired, then you mark the breaker that information should be there. Now, where might you see that? A good example on DC systems. They take a circuit breaker, one circuit breaker, and they take the one conductor and they wire the poles. So you have A to B, say you have A, B, C, D, E, F. A to D is one pole. B to E is the second pole. C to F is the third pole. They'll tell you how to wire that so that you come in on A, come out on F, and you basically serpentine the circuit so that you have 3 poles stopping the flow of DC current. That is a requirement for some circuit breakers and fusible disconnect switches. Same thing. You have to follow the manufacturer's instructions. There's reasons for that. There's reasons that for, say, a DC application that you need to wire it a certain configuration, then it'll be marked to indicate there are additional instructions for the installation. So the manufacturer's instructions will have marking requirements. All right, so let's get out of that one. Yeah, so there's a whole section in UL 489. Here's the section in UL 489. So section 9 is titled Markings. General. You have your general information. You got your interrupting ratings, any special markings. You got current limiting circuit breaker, instantaneous trip circuit breakers, circuit breakers and ground fault circuit interrupters, circuit breakers with equipment ground fault protection. So these are all the different types of circuit breakers that you may have that you have to provide special marking requirements. So if a circuit breaker has some functionality that is a little different than just a standard thermomagnetic circuit breaker or even electronic trip circuit breaker, if there are special features that that breaker brings to the table, then the standard is going to tell you any special marking requirements. All right. Oh yeah, and there's the switch duty too. So if you look, there's hacker breakers, and there could be a switch duty as well. All right, so they tell you also the location for circuit breaker markings. Trying to get my, geez, oh man. All right. Oh, location markings, you remember? Here we go. I'm going to give you the location markings. This is out of a table in this is out of a table in the standard. So remember we saw location B. So location B, so here's your locations. There's a B, a B, a B, and it says see notes. And if you look at what B says, B is right here. Marking shall be visible without disassembling or removing device, and shall be visible when the trim or cover or enclosure is removed and may be visible with the trim or cover in place. So you have to have the type designation, the manufacturer's name, the voltage rating, the frequency, and the ampere rating, and the line and load. Those are the ones that have to be visible without disassembling or removing the device, and be visible when the trim or cover of the enclosure is removed. Now, this is important. Why is it important? Because you've got to realize there's only so much real estate that you have. And circuit breaker manufacturers don't have stock in these and magnifying glasses. Okay, it's very important that we understand there's only so much real estate that you have on a circuit breaker. So you have to be picking, you have to pick and choose. You have to say what goes where. So that's locations B. What is A? Marking shall be visible without removing the trim or cover of enclosure. So that is the open and closed, and that is the ampere rating. Those are the only two items that have to be visible without removing the trim, cover, or of the enclosure. So it makes basically you open the door and you need to be able to see what is the ampere rating for 100 amps and less, and then what is on and off. Okay? And what's D? We already talked about B. Oh, there is a C. Marking may be on any convenient location except on the rear. And that would be any special characteristics. And then F is part replacement marking need not be visible when removed part is installed. And then there's a D. There's a D down here. Marking of tripped and reset need not be provided if on intended receiving device. Oh, there's an I too. Marking may be anywhere on the circuit breaker. That's the I, that's the factory identification. You can put that factory identification anywhere, but it has to be on the circuit breaker. There's a J, which isn't in the table up above, but a J is shipped with the circuit breaker, so that means it could be on the instruction leaflet and whatnot. K is marking needs only be visible after removal of the circuit breaker frame, cover, or equipment. And then I think we cover them all. Did I cover E? On, off marking need not be visible on circuit breaker if on electrical operator. And that would be, what that means is, like, let's say you have a circuit breaker that is in an assembly and you have a handle on the outside that says on and off. That's what that provision gets you. Okay? Clear as mud? Getting better? Oh, here's some pictures. We love pictures. I'm going to go straight to the iPad. So there we go. So this is a good example of what's on the face of the device. You have the combination AFCI. You have the type designation from the manufacturer. You have the identification of the manufacturer. You have that this is a hacker type. You have aluminum and copper on the front. You have the frequency on the front. And we've got the interrupting rating and the voltage on the front. We have the ampere rating, and we have on-off. So there's a lot of information on the front of that one. Here is the front of this one. So you have the type, you have the manufacturer, you have the voltage, copper or aluminum, hacker, how many poles. You've got the UL and CSA listing marks. You've got on-off, and you've got the current rating. There's a lot of really good information there. All right. Oh, and this is, look at that, common trip. All right, and let's see what else. This one's interesting. This one doesn't have markings. I mean, I've got on, I've got 40, I've got on and off, I got CUAL. I'm not sure what that, I think that this handle says common trip. really hard to tell. And I'm not sure what that says. But not much on the front of this circuit breaker. Here's another one. This is a Siemens breaker. You've got the number of poles. You've got the type. You have the interrupting rating. You have the voltage, hacker, issue number, etc. The fact that it's UL listed. You have off. And I'm hoping, yep, and you've got on, and you've got the current. A lot of information on the face of this device as well. Although that doesn't look good. Anyway. Okay, now let's take a look at the next question. Do codes and standards address durability and visibility of required markings? If so, what are those requirements? All right, so let's take a look. The standard says, oh yeah, so the markings of circuit breakers shall be durable and legible. The determination of the durability of the marking shall take into consideration the material used, the security with which the marking is attached, and the degree of abuse expected because of the marking location. So you got to think about it. Your markings could be just in a really bad spot, right? Try to make this bigger. Hopefully, can do that without causing too much heartburn. All right. All right, so I knew I would cause some heartburn, but I didn't realize it was going to be that much heartburn. There we go. There we go. All right. Permanence of markings. An adhesive-backed label shall comply with the standard for marking and labeling systems, UL 969. So they reference another standard. So the point here is, when it comes to durability, there are requirements, and we could have debates on whether or not some of these labels are actually very durable. Now, the durability is not defined per se, but based on that other reference, what was the standard? It said this is permanence of markings, which I could say, well, that's a factor of durability. An adhesive-backed label shall comply with the standard for marking and labeling systems, UL 969. Labels that come in contact with uninsulated live parts shall be of non-conductive material, that, obviously. So we could have a debate on whether or not the durability is there. Visibility. Now, visibility there are references in the standards to help you understand the location, which we just went over, right? There was a table that talked about where these labels may be or are mandated to be located, and where there's permissions if you can put them anywhere on the device itself. But remember, you're dealing with real estate issues, right? And we have a lot of required markings, especially when you think about a dual function. Say you have an AFCI and a GFCI device. You've got to put all of that information to be visible, plus the voltage rating, plus the handle rating, plus the on. There's a lot, okay? So there's a lot of debate that goes on in the standards development process on where do we mark these devices, especially the smaller they get, the harder it is, and the more likely that you are permitted to have an instruction sheet to complement the device. The only thing you have to be able to do is get the instruction sheet married with the device, and that's usually done via a catalog number. All right? We already went through the circuit breaker marking. Now, all right, so that's the durability and visibility. Now, let's talk about the next question. Let me do this. Does the NEC require an Ampere rating to be marked on circuit breakers? If so, is that marking required to be visible and located in a specific location on the breaker? We already went through this. We already talked about this. So here's the Ampere rating. The Ampere rating of a circuit breaker rated higher than 100 amps shall be visible after removal of a trim or cover. Okay, location category B. Remember, we went through that. You can rewind this video and go take a look at that table. The Ampere rating of a circuit breaker rated 100 amps or less has to be molded, stamped, or etched into, ink stamped, or similarly marked on the handle or the escutcheon area of the circuit breaker. So this is location category A. We've got to be able to see this through the dead front. If you look at any residential panel board, that's where you're going to see a lot of the 100 amps or less, right? You have to be able to see that. It's typically going to be on the face of the handle. And you'll see that on the bigger breakers too, but you'll always see 100 amps or less. It's going to be on the handle. It's going to be visible with the dead front on. If you can't see the label for the Ampere rating, you may have to remove the dead front. That is going to be greater than 100 amps. Which doesn't make sense to me. Think about it. I mean, do I want to remove a dead front on a large breaker to see what the Ampere rating is? Now, most of those are going to have electronic trip units and all that jazz, and you're going to have all that information through the... I don't know. What are your thoughts on that one? Love to know. All right. Well, look at this puppy. There's no marking on this at all. If there was a marking, I see the on-off. I see on-off, but I don't see much more of anything there. There's your 20 amps. So that's on the handle. That's going to be visible with the dead front on. There's your 20 amps, visible with the dead front on. Now there's a 225. Now that is not required to be there, because remember the standard says 100 amps or less. Here's 125. Now we could have a debate and argument. I don't know where. It looks like the escutcheon would go like right in here. It looks like this would protrude through the dead front. It would have to, because you have a push to trip button. So that's all visible. All of that whole label is visible through the dead front. But you'll notice it's not on the handle at all. It's over here on the label. And it's 125, so it's not required to be in that location. All right? All right, let's move to the next question. Does the NEC require an interrupting rating to be marked on the circuit breakers? If so, is that marking required to be visible and located in a specific location of the breaker? Good question. Well, thank you. You're welcome. Interrupting ratings. A circuit breaker having an interrupting rating other than 5,000 amps shall be marked with the interrupting rating or ratings which has been found acceptable in accordance with blah, 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 blah. We're looking for a location. There it is. Location category B. Except as permitted, the current interrupting rating of a circuit breaker shall be located where it will be visible when a front or trim is removed. If there is more than one interrupting rating marked on the circuit breaker, all such ratings shall appear together. 9133 says a circuit breaker that is 1.5 inches wide per pole or less shall be permitted to have the marking at any convenient location on the breaker except on the rear. And that is location category C. All right, so you may see that some of those, and it says 1.5 inches wide per pole. Those are going to probably be your smaller circuit breakers. And I'll bet you'll find some manufacturers put those on the side. Interrupting ratings, B and C. Marking shall be visible without disassembly. And C is marking may be on any convenient location except the rear. And that will be dependent upon, again, 9132 or 9133. All right, so my answer to that question would be it depends on where, but you're always going to have an interrupting rating marked on the device. Here's a Square D device. There's your interrupting rating right here. And this is a 150 amp breaker, so this is at any convenient location that would not be visible through the dead front. This is a 200 amp device, and this is the dead front, so this is all visible through the dead front. This is visible through the dead front, right? And the interrupting rating is where? Interrupting rating. Where is it? Where is the interrupting rating? I got catalog number style. Here it is, interrupting RMS. At this voltage, 25,000 amps. So the interrupting rating would be available through the dead front. Now this one here, so you can see where the dead front goes. The dead front would go here and here. All right. All right. So you have the Ampere rating, which is visible, and there's your 22K AIC. So this is a 22K GE breaker. This one is on the side. There's your, now you would have to actually remove this circuit breaker to find its interrupting rating. All right, so answer, yes, it's required to be marked. Where? It depends. Depends on the rating and a couple of those areas, so take a look. You can always rewind and pause this video. All right, we've been going for 37 minutes. All right, here's the next question. Does the NEC require circuit breakers used to switch lighting to have specific markings? If so, is that marking required to be visible and located in a specific location on the circuit breaker? If switch marking is required, does it apply to breakers or branch circuits, feeders, and services? Very good question. So, if you go back to the standards, first of all, 240.83 has requirements for circuit breakers used to switch fluorescent and HID lighting circuits. An HID, so this is what it says. So this is out of the standard. 50 amps or less circuit breakers rated 480 volts or less may be marked HID, meaning they are suitable for switching high-intensity discharge, fluorescent lighting loads on a regular basis. The breakers may employ a different construction than a standard switch-duty circuit breaker in order to address the high inrush currents. So, typically, what they're going to do here is we're going to have, in the standard, a different angle. Remember, whenever we have, think about a circuit breaker. What's a circuit breaker doing? A circuit breaker is going to be opening and closing contacts, and it's going to be drawing an arc between those contacts. The characteristic of that arc is going to depend upon the power factor of the circuit that you're trying to open and close on. Now, power factor. Let's think about power factor. It will vary. If I'm dealing with a specific type of light, like fluorescent or HID, they'll know the type of load that we're dealing with, and then that sort of gives you an indication of what that current power factor is going to be, so we can test under those inrush currents at those power factors. Now, another thing we got to remember, if you're switching lights on and off, that might happen more frequent than a standard breaker that just sits there and maybe gets cycled during maintenance schedules, which is not daily, definitely, and not multiple times a day. So what you'll see in the standard is that we will put these circuit breakers through tests from an endurance perspective under a current draw that is indicative of the load, and probably a worst case scenario of that load. Make sense? So here's an example. 715.1, a circuit breaker rated 50 amps maximum, 480 volts or less, and intended to switch high-intensity discharge lighting loads on a regular basis shall add, in addition to other requirements in the standard, be subjected to endurance tests and temperature tests. So look at this. Subjected to temperature tests, 7.14, after 999, 1,000, 1,001, 2,999, etc. operations of endurance. The load shall have a power factor in the range of 45 to 50%. Remember I told you about the power factor. I'm looking at the current that I'm interrupting. Remember, when I have a good idea of what the load is, if I'm going to design tests for a specific load, if I know the characteristics of the load, I subject the device to those characteristics over and over and over from an endurance perspective, and that gives me a better flavor for whether or not that product is going to survive. And if I'm the design engineer and I know I'm going to be receiving these harsh tests, I may have to change my design to meet these performance requirements. A circuit breaker intended to switch HID lighting loads on a regular basis and complying with performance may be marked HID in location B. So it tells you the performance test requirements that you need to pass and the marking requirements. There you go. So there's an SWD down here. That's a switch duty. That's your fluorescence. Here is Hacker SWD. These are all SWDs. Let me go back to. All right, so I think that answered that question. We saw SWD and HID, and if I go back and look at SWD, you're going to see that there's a specific type of load, which is your fluorescence, your compact fluorescence and your fluorescent lighting, your fluorescent tubes. It's switch duty. It has to go on and off. We test those at a specific power factor and for a number of cycles, just like we do HID. The HID is a different power factor. So we match the test with the type of load, and we cover endurance. All right, so what's this one? If circuit breakers used to switch lighting are required to be marked for that application, is the marking the same for incandescent, fluorescent, HID, and LED? Oh, very good question. So I know I have this is an SWD. HID is HID. I don't have a switch duty for LED lighting, and I don't have anything special for incandescent. So SWD is switching fluorescent lighting loads on a regular basis. Switch duty rated circuit breakers shall comply with the construction requirements, all types. There's your fluorescence, subject to the endurance temperature tests. There's your cycles. I don't have a power factor, though, specified for this, like I had for HID, if you remember that one. Switch duty circuit breakers. A circuit breaker intended to switch fluorescent lighting loads on a regular basis and complying with switch duty rated circuit breaker section 17 shall be marked SWD location category B. Remember, I can make it so you have to remove the dead front to see that label. All right, so hopefully that answered that question. Here's the next question. Does the NEC require a voltage marking on circuit breakers? If so, is that marking required to be visible and located in a specific location? There's your voltage. Remember in 489, voltage has to be location B, which means the marking shall be visible without disassembling or removing the device. It shall be visible when the trim or cover or enclosure is removed and may be visible with the trim or cover in place. So I may have to remove that trim cover to see the voltage rating. And that's per UL 489. All right, and keep in mind what the slash rating. So there's your voltage rating on this breaker here. And this one would be visible with the dead front. Yeah, the dead front is on. Oh, because I believe the dead front goes right down this way. That's where your dead front covers. So this is all hidden. That's all hidden, but that label is exposed. Does the NEC require a circuit breaker marking to indicate the breaker is open, off, or closed on? If so, blah, blah, blah. There it is right here. Open and closed is location A. Marking shall be visible without removing the trim or cover of the enclosure. So you have to be able to maybe open the door, but not remove any trim and know whether that breaker is open or closed or on or off. So this is a good example. See how they have the on and the off and the dead front. The dead front could be anywhere on this. I mean, it could be here. You could see this, or you could just see a portion of this. Depends on the assembly. Okay. This one's installed. This is in a diesel generator, and all of your information is right here. All right, let's talk temperature. Many circuit breakers have a temperature marking. Is that marking required by the NEC or product standards? If required, is the marking required to be visible and located in a specific location? What are the limitations associated with the marking? Well, here's what it says in the UL standard. A circuit breaker that is intended to be operated continuously. Oh boy. All right, so here's what we got. So now we're getting into continuous. All right. You'll have a 100% rated type of breaker, and then you'll have your 90 degree C, 75 degree C, what the lugs, what the circuit breaker temperature is for the assembly. So, two different things though. I mean, they're related. So the 100%, let's talk about that. We might close on this one. Fact. So if I have a circuit breaker that is, say, 100% rated, what does that mean? That means that if the handle is 100 amps, then I can handle 100 amps continuously. If it's not 100% rated, then that 100 amp breaker, if it is carrying continuous current, could only handle 80%. And it has to deal with heat that's generated. It's a heat rise discussion. And I'm looking for, here it is. I think I found it. I think I can. That label. All right. So, I'll explain this. If I have let's do this. I'm just going to show this. So let's say that I have a 100% rated breaker versus 80%. 80% is basically what you have every day of the week, twice on Sunday. If it's a 100% rated breaker or fuse, you need to think about UL 489, but you also need to think about the assembly. Why is that? Why, Tom? Why? So here's out of UL 489, 100% rated circuit breaker marked for use at 100% of its rated current shall be tested as described in the smallest enclosure in open air. So 100% rated breaker shall be tested in the smallest enclosure or cubicle within which it is used. So when you have a 100% rated circuit breaker, it's not about the circuit breaker alone. It's, I would argue, more about the assembly than it is about the circuit breaker. Because you have to maintain a temperature rise when it's in its enclosure. So the way we set up the tests in UL 489, you have to test it in an enclosure, and then you look for a temperature rise. It says the temperature rises where connections are made to external bus bars, when bus bars are used, or on a wiring terminal at a point to which the insulation of a wire is brought up as in actual service when tested with insulated wire shall not exceed 60 degrees C or 100 degree F. That's the temperature rise. If marked in accordance with 91214, the marking shall be permitted to indicate only specific current ratings if a rating less than the frame rating does not exceed the 90 degree F temperature rise. So you have to think about the size of the enclosure, and in some cases, the assembly will use, say, for example, it may use a specific type of high-density copper bus, okay? Because it's about getting the heat out. If you think about when you do the 80%, how does this work? What's the approach? So what we do first is we will calculate the load, the continuous and non-continuous. Then, for the continuous loads, say it's a 100 amp load. I take a 100 amp load. If it's continuous, I have to take that times 1.25. So then I multiply 100 amps worth of load by 1.25 and I get 125 amps. Does that mean that my load's going to be 125 amps? Absolutely not. It just means it's going to be 100 amps continuously. So I say the load is actually 125 amps. And then what do? I pick a conductor for 125 amps, which will be a larger conductor. Physically larger too. When I pick the 125 amps worth of conductor, then I pick an overcurrent device to protect 125 amps. So I'm not operating the circuit breaker more than 80% of its rating. So that's a very important piece of the puzzle. And you'll see in manufacturer's instructions where look at this. Look at this. This is out of a manufacturer's instructions literature. Look at this right here. 100% rated circuit breaker requires copper bus. Not available in type 12, 4, and 4X enclosures. So you're not going to see an aluminum bus in a panel board or switchboard or whatever it is you're using 100% rated devices. It tells you it's more than just the circuit breaker. So from a marking perspective, you've got to think about, you've got to get out of the box, so to speak. You've got to understand the fact that your application for that 100% rated breaker is more than just the breaker. It's the assembly as well. Okay? So, a circuit breaker that's intended to be operated continuously at 100% of its rating and that has temperature rise on a wiring terminal exceeding 90 degree F shall be marked location category B for use with 90 degree C wire and the wire size. The wire size shall be based on the ampacity of 75 degrees C rated conductors as indicated in table 61421. Interesting. A circuit breaker that is intended to be operated continuously at 100% of its rating and that has a temperature rise exceeding 90 degrees. So you could see a circuit breaker that says use 90 degrees C conductor at its 75 degrees C ampacity. But the reason is, or the application would be when used at 100% of its rating. I'll bet you, I just recently got this question. And you know what? I'm hoping I answered it correctly. Somebody pointed this out to me on a circuit breaker that they took a picture of, and it said to use 90 degree C conductor at the 75 degree C ampacity. And they said, why can't I use a 75 degree C conductor? And they could as long as they're not operating it at 100% continuously. The reason that note is on there is not for when you're using it at doing an 80% rated application. The only reason you have to use 90 degree C insulation is when you're using it at 100% of its rating. Tell me that's not an interesting one. I gotta go find that email now. I love these moments. Don't you just love these moments? They're like, you realize at some point in time, you realize you never stop learning. So temperature ratings and markings on these devices, on circuit breakers, are going to be driven by the standards. Now, it wasn't until the 2023 code cycle that circuit breakers, low voltage circuit breakers, and fuses were required to be listed. Chew on that one for a little bit. All right, everybody. It's been an hour. I really appreciate you hanging in there, taking the time out of your day to watch something I recorded well past midnight the day before. So I hope you got something out of today, and I hope that I hope you are safe and healthy and ready for Tech Tuesday next week. Stay tuned, take care, stay safe, and please stay healthy. See you next week.